Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thanks for the occasion that given to us. In this moment, we will explain our report in subject Physics Experimental 1 in Photonic Laboratory, Erlangga University, with the title of 3 Laser Diffraction. Thank you for our supervisor, Mr. Herri and Mr. Samian, for this change. My name is Gunarti Melinda Putri, and my partner, Safira Wahyu Nur Aziza. The purpose of this to show the laser diffraction phenomenon in small slit diameter and to measure width of small slit diameter with laser diffraction methods. The materials are helium neon laser pointer, photocell optical detector BPY47, optical bands, multi-clamp, connector cables, diffraction grating, and microvoltmeter. This is the observation dates that we got in this experiment. This is the picture 4, graph of intensity distribution between shift millimeters and voltage volt. And this is the results of delta S or minimum gap measurements. And my partner will explain the analytical dates and more.
Okay, from the experiments, we got wavelength 6.238 multiple 10 exponent minus 4 millimeters, and length from the layer is 1910 millimeters. And we got delta S or minimum gap measurements 9.88. In here, we need to find the value of D or small slit diameter. After we calculate it with the formula, as we can see in the screen, the value of D is 0.12189 millimeters, and we calculate the uncertainty value of D. Delta D is 0.0061984 millimeters. In this analytical data, we calculate trial error percentage, and we got 1.55%. With literature of it, around 0.12. Here we are for discussion of this experiment. In this experiment, we need to find about laser diffraction phenomenon and find the value of small slit diameter with laser diffraction method. The materials are helium neon laser pointer, photocell optical detector, or BPY47, optical bench, multi-clamp, connector cables, diffraction grating, and microvoltmeter. The experiment starts with turn on the photocell and microvoltmeter with connector cable. After that, we need to move the photocell from end to end, from right to left and left to right, every 2 millimeters. In here, we took 3 result output voltage that we turn on microvoltmeter. We got around 642 data there from this experiment. After that, after we knew all of the data that we need, we calculated delta S, our minimum gap measurements, and we got 9.88 millimeters. And then we calculate D, our small diameter, and we got D 0.12186 millimeters, and for trial error percentage, and we got 1.55%. The conclusion from this experiment are: first, with laser diffraction method, we can know that slit diameter or D will occur when the laser passes the white screen and will project the diffraction pattern. The intensity of laser will give us diffraction pattern and change it by photocell as electrical signal and detected by microvoltmeter. Second, the value of D is T plus minus delta T 0.12186 plus minus 0.00964 millimeters. With trial error percentage, with the trial error percentage, 1.55%.
Subjection. The subjection that the observers need to do are the observer must know the procedure before do the experiment and this experiment. And second, the observer need to be more focused to observe and more careful to take the dates, especially when the observer read the full text output from microphotometer and move the photocell. Bibliography. And these are the bibliography that we use in this experiment. Okay, thank you so much for your time and the attention. And we would like to apologize if there is a mistake. We hope you have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.